And now that, oh, there it goes. Okay. Here's your warm up, guys. You got flies in the house, so you can know how to read. Pause the video, work on that because we are ready to go. Let's do it. Okay, so here we go. The story goes you've got flies in the house, and every 8 days, this fly trap can catch 12 flies. So we're going to make a table of values. And how did you fill in your table of values? Let's see here. Addie, how did you fill in your table of values? What did you put in for your X's? Addie D.
Oh, well, I just did 10. I just did
10, 20, 30, 40. So we'll go 0, 10, 20, 30, 40, 50. Okay, and then how many flies were we catching after 0 days?
0.
Okay, how about after 10 days?
I'm a little unsure if I did this right.
Let's see. Tell me what you did.
Oh, well, I just did that at 12 by 18.
Or 12 by 8?
Yeah, sorry.
Let's try. Okay, 12 flies per 8 days. That makes sense to me. That would give you, I think, a 1.5 flies per day.
And then I times it by
Sure.
10, which was 15.
And then 420.
30.
And then
40.
45. Mm-hmm.
60.
She's on it. Perfect. Works for me. Were you able to use this to come up with an equation?
Yeah.
What did you come up with?
I got y equals 1.5x.
Awesome. Very good. How many of us follow what Addie did and see how she did that and are feeling pretty good about that? Beautiful. Very good. All we have to do now is we're going to tidy this up a little bit. And to do that, one thing is we're going to turn this into its preferred form, which is an improper fraction. Y equals 1.5 is y equals 1.5 x, which would be the same thing as y equals 3/2 x. Now, why do I prefer that? You're all going to see it in just a moment, okay? So the other thing I want to do is, did anybody else count by something other than tens on your x's? Did someone count by something else? Liam, what'd you count by?
8.
By eights? I like that. I wonder, did anybody count by something else? There's something actually specific I'm looking for, and you're going to see why in a minute. Skylar, what'd you count by?
4.
Fours? Do I want? I did it. Then that's good too. But I'm actually looking for something a little bit different. Addie,
I did 2.
twos. Here's why I'm counting by twos: 0, 2, 4, 6, 8, 10. Addie, how many flies were 0?
0.
How about 2 days?
3.
And then?
6.
And then?
9.
And then?
12.
And then?
15.
15. Very good. Now, there's a reason that I really like this table and I really like this equation. Part of it is their relationship. If you check it out, guys, we'll get into that. We'll get into that. Let's see here, guys. It is the 70th day of school. Since 70 is abundant, but not, I should say, semi-perfect. Excuse me. Not semi-perfect. It is the first weird number. So a number is abundant if its proper divisors add up to more than itself. So that is, all the numbers that go into 70 other than 70 should add up to more than 70. Okay, other than 70, what goes into 70? Go. 10, 7, 35, 2. Can't do 70, can't do itself. 1, 5. There's one more. It's a weird one. You don't think about it as going into this number, but it does. Did I hear it?
14.
14, yeah. Now, if you add all those up, that is, let's see here. Do I get something more than 70? 10 plus 7. I should, because that's for the plus 35, plus 2, plus 1, plus 5, plus 14. 74. Very good. However, I can't add up any combination of these things to make 70 exactly. That's what it means for it to be semi-perfect. I can't take any combination of these numbers and add them together to make 70 by using each one only once. And so that's why it's a weird number. Happy day of celebration for the business of popping corn. So it turns out before microwaves, it was really hard to, popping corn was a process. And that's why there used to be, I don't know if you guys have ever seen on 21st South that abandoned popcorn factory. Have you guys seen that? The store? It's like a spooky abandoned popcorn store. Anyway, there's one on 21st because apparently when you used to want popcorn, you couldn't just microwave it. You had to go out and buy it from somebody who professionally popped corn for a living. And then microwaves came along and microwave popcorn came along. And they said, you know, that they're taking the jobs of these hardworking professional popcorn poppers. So we named today the day of celebration for the business of popping corn. Save the popcorn poppers.
Yeah,
It did not work because microwave popcorn is so easy. And still, it's like, you know what, though? It's not the same, is it? It's not the same. Like, what's that? It's on 21st, and I want to say 21st South, and I want to put it at like maybe 10th East, there's abouts. But there's an abandoned popcorn store there. That's real spooky. And you can still see all this old popcorn, bags of popcorn in there. And it's been abandoned for as long as I've lived here, which is a long time. What's our first essential question? And I would love to get that from Miss Penny. Let's write that down. How can we keep track of a proportion by graphing it on a coordinate plane? Right. What is our second essential question? And I would love to get that from Henry. Let's have a quick talk about how to play the scoreboard game level 3. So the scoreboard game level 3 works a lot like the scoreboard game level 1 and 2 and 0. We're still keeping track of all the same things. There's still the Stars and Moons team. But you guys know how if we're winning the scoreboard game, the last 5 minutes you get to yourself, and if you're on the star team, you can wander around. Do you guys know what I'm talking about? So from here on out, guys, I'm actually going to keep track of how many points each period has. For example, yesterday, so they got 0 today. But yesterday, all my classes got 1 point except for my 5th period, which got 2 points. And then I'm going to keep track of that on here. Whichever period has the most points each day here, at the end of class, if we win that scoreboard game and get those 5 minutes, everybody can get up and wander around. Does that make sense? So the entire class can go and hang out and do whatever it is that they're doing as long as they're not making it weird. You know what I mean? Like a lot of times people will hang out by the door and like push each other into the door, and like I don't like that. But that's the idea here. And that's really the only difference. You guys feel ready for that one? Yeah. Perfect. Our Jeopardy this week is national birds. The national bird of India is this bird, the males of which are known for their enormous and extravagant tail feathers. It is not a pigeon or what it is. Yeah, Luke, go ahead. It is a peacock, an Indian peacock. And then snowbank is what I'm looking for, snowbank. Alrighty, let's do it. You know what? Underneath all this, got a pencil? Today, we're going to be graphing proportional situations. Graphing proportional situations. Thank you. Thank you so much. Perfect. Yeah, just pop it right there. Now, guys, since we're going to be graphing things, I have right here a ruler. A ruler. I'm going to give you guys each one of these rulers, okay? But you need to know a few of my ruler rules, okay? So my rulers are, first of all, guys, don't write on my rulers, okay? Don't write on my rulers. You might see little odd ticks and tacks on there, like someone was graphing and then a little bit of pencil gone on it. That's not a big deal. But don't go writing stuff on there and drawing on it and messing with them. Each day that we collect our rulers, I'll have one person at your table check each ruler to see if they've been vandalized. And if they've been vandalized, they'll let me know about it. And if they let me know about it, we'll have to figure out who did it. And no, thank you. We'll charge you for the ruler. I just don't understand what it is about rulers, but I swear, when there's just a type of student, and I don't know who it is, but it's just a type of person who, when I hand them a ruler, they're like, oh, look, a ruler. Look, someone wrote on it. They said, have a nice day. I should write something on it too, but what? Oh, I know. The most racist thing I can think of. And done. How many of us have gotten that ruler before? Like, what the heck? Why? Why are people doing that? Don't do that to my rulers, please. Also, guys, don't swashbuckle with my rulers. Like, do little play sword fights. Like, aha, right? Like, don't want to get splinters. Also, it's distracting. The other thing, guys, and this is actually more of a me problem than a you problem, don't tap my rulers. Like, people sometimes get their rulers and they're like, and the thing is that here's the deal. I remember there was a student who was like, oh, my friend and I, we learned Morse code so we can talk in class. So I could be like, right? And the thing is if people are talking in my class, you've probably seen it happen a million times. I'm like, hey, excuse me, please stop talking. The end. But I'm going to tell you guys, if I was up here teaching and I heard like, I'd be up here and I'd be like, stop tapping! I hate the tapping sound. It drives me crazy. I do not like it. So go ahead, guys, grab a ruler, look it over, drop it on the floor. Make sure that there is no vandalism. If there is, please let me know, and we'll get this going. Go, everybody grab one of these. Check them to make sure there's no vandalismo. And let me know if there is. Little ticks and tacks are no big deal. What we're worried about is writing, drawings, big marks. Oh, I already gave it to you guys. Beautiful. Okay. Come on up in 5, 4, 3, 2, 1. That was a great countdown from 5. And thank you for not immediately doing all the things I told you not to do with your ruler right away. That's a very much appreciated. I think you guys do deserve a point for it.
Oh, yeah.
That was a really good mighty oh yeah, and you guys deserve a point for that.
Oh, yeah.
You'll love to see it. Okay, let's talk about the parts of a coordinate plane. So we're going to draw a coordinate plane, which looks like a big plus sign. A coordinate plane is really actually just two number lines that have been glued together. There are two number lines that have been glued together. And positives go like this. 1, 2, 3, 4. Negatives go like this. -1, -2, -3, -4. Positives go up. 1, 2, 3, 4. Negatives go down. -1, -2, -3, -4. That's all there is to it. It's just a coordinate plane is two number lines drawn together like this, okay? These two number lines have two separate names. They're called axes. Do you guys remember what this one is called? The one that goes left and right? Does anyone remember, Skylar? That's the x-axis and represents all the x values. And does anybody remember what this up and down one's called, Manuela? The y-axis. Very good. That represents our y. Our x-axis is our independent variable. Our y-axis is our dependent variable. This is split up into 4 quadrants. This is quadrant 1 on the upper right. This is quadrant 2 on the upper left. Quadrant 3 on the lower left. And quadrant 4 on the lower right. How many of you have always been seriously annoyed by the way that those quadrants are counted off? Yeah, it's obnoxious. But the reason this has to be quadrant 1 is because this is where the x is positive and the y is positive. And that's like 99% of real life situations. Real life situations generally happen in positive numbers, right? Like you're not going to say that in -8 days, -12 flies got eaten. You know what I mean? The coordinates go x, comma, y. So for instance, this point right here is 2 on my x-axis, 1 on my y-axis, which is why the coordinates of that point would be 2, comma, 1. 2, comma, 1. Take a look where I put that right there. I went over 2, up 3 right there. When I say teach, I want you to say, okay, what are the coordinates of that point right there? Teach, teach. Okay, can I get you guys back in 5, 4, 3, 2, 1. Luke, what do you think here? What is the what would the coordinates of that point be? -2, comma 3. Very good. How many of us got -2, comma 3 for that? You'll love to see it. What if I asked you a slightly different question? What if instead of telling you a point and then having you put it down, What if I asked you to graph 3 comma negative 4? Where does that go? Which quadrant and where? Teach! All right. All right. Let's see if I can get a little bit of help out here. Let's get it from Tommy. Tommy, will you please put down the point 3 comma negative 4 onto my coordinate plane? Onto my coordinate plane, please. Beautiful. That looks great. How many of us got our 3 comma negative 4 there? You guys feeling good on that? You guys okay on there? Beautiful. Very good. That's just a kind of a review of how the coordinate plane works and all of its pieces so that we can talk about it like a grown-up. But now, guys, we're going to come back to this. We're going to come back to this thing we did in our warm-up. So I'm going to copy that, get a new thing going. We're going to paste it. And then I'm going to grab this because that was the other one. I actually didn't want this, though. There we go. I'm going to copy that. I'm going to paste it here. You should already have this information lying around somewhere. If not, just copy it somewhere nearby so we can see it. We're going to make a coordinate plane that fits this. And again, the reason that quadrant 1 is the one that we start in is because it's where most of our stuff lives. Let's use our ruler to draw a plane in quadrant 1, excuse me. Draw a plane just in quadrant 1 because I'm not worried about negatives here. We're not time traveling with our Venus flytrap, and we're not talking about ghost flies. Right? I don't know what negative flies would mean. And you know what I'm going to do? I'm going to count by 2s up to 10. Then I'm going to put the little singles in there. Then I'll count by 5s up to 20 perhaps. 5, 10, 15, 20. I'll put the little singles in there. Nothing too crazy. There. That's what I'm looking for. Something like that. A coordinate plane. The first quadrant. Yay. Now here's the thing, guys. All of these parts of a table are actually also ordered pairs. So for example, 0, 0 is the point 0, 0. And I can graph that. 0, 0, that's just right here. Does anyone know the special name that we actually have for the point 0, 0? There's a special name for it, Tice? Origin. The origin is correct. The next one is 2, 3. So 2, 1, 2, 3. 4, 6. 6, 9. 8, 12. 10, 15. Something like that. Okay? Did anybody notice anything interesting about these points here when you lay them all out like this? Emmanuel, what do you notice about them? It goes in a line. That's right. How many of you noticed that this goes in a line? This goes in a line. Beautiful. And how many of us want to connect them with a line? Just wait 1 second, because here's the problem. If I connect them with a solid line, you're saying something very specific about this situation. You're saying, and don't do this just yet, put your pencils down. So if I connect them with a solid line, don't do it yet. You're saying all the places in between make sense in this story. For example, you're saying that this part of the story makes sense. You're saying that this part of the story makes sense. You're saying that this part of the story makes sense. When I say teach, I want you guys to say, okay, do you see anything wrong with thinking about what those points that the X's are on might be conveying about my story here, about flies and days? What do you think is not so good about those? Give it a shot and teach. Okay. Can I get you in 5, 4, 3, 2, 1? Let me zoom in. What is this red point actually saying? This is what, comma, what? What would that be? What, comma, what? What would that be, Nathan? Yeah, 1 comma 1.5. That is, after 1 day, your Venus flytrap has caught 1.5 flies.
That's correct.
Well, that's true. It's catching 1.5 flies per day. That's the unit rate. But is there ever a time it actually catches 1.5 flies? Could someone explain why it can't catch 1.5 flies? Why can't that work? Yeah, Liam.
Because it can't be like half of a fly.
Yeah, if it's like bit down on a fly and the fly is stuck, is that fly caught or not? It's caught, right? So you can only catch a whole fly. That's why we would connect it with a dashed line instead of a solid one. Got a pencil? So if you have a situation where the values in between don't make sense, you use a dashed line to connect them. And it's a solid line if they do make sense, okay? After seeing this once, how many of us feel like if I asked you to create a table, an equation, and a graph to represent a situation, you feel like you could do that okay? Okay, let's try another one. Let's see here, guys. Let's just go ahead and write a quick thing about a soft serve machine. You guys know what I'm talking about, a soft serve machine? So it's like one of those machines where like you pull the handle and it's just the ice cream's like coming out like that. And let's go ahead and say that in 10 seconds, it can distribute 6 ounces. 6 ounces in 10 seconds. Can you make a table, an equation, and a graph representing how much ice cream comes out of that machine based on how many seconds you've got it running? Give it a try and teach. Hmm? I think so. I think it is. Well, you can check though. You can check if there's something wrong. Like if you're like, hey, my Canvas grade says this, but my focus grade says this. Let me know and I'll change it. But I think they're talking to each other again. It is. That is correct. Very good. And then can you give that to me as a fraction? I'd actually like to look at it as a fraction. Uh-huh. And your calculator will do that if you hit the little arrow keys. Do you know which ones I mean? These ones down here. So type in that number you just told me.
Oops, not that.
And then hit that button. Now hit enter. There you go.
Wait, that's actually. Will it be marked wrong if I put a decimal on my skill check?
Yes. Because I need it as a fraction, and you're going to see why shortly.
Is,
Trust me, you want it as a fraction. I didn't tell you, did I? What do you think? I'm going to leave it up to you. Yeah.
Do you say you can turn this into a fraction?
Yeah. Hit that little button right there. Doink. Oh, sorry, the one above it. There it is.
Oh,
You're good. We'll show that to everybody. We'll show that to everybody. Looks like that not everybody's aware of that thing, so let's see what we can do. Okay. How's that coming, guys? You guys done or you want another moment? Let me see. Let me see. Thumbs up, all done. Index finger, you need a little more time. Wave your hand, you need a lot more time. Thumbs down, you're stuck somewhere and need some help. Where's everybody? Okay. Let's keep going for it, guys. Let's give you another minute 20, and then we'll talk to each other, see what we can manage. Yeah, so the dashed line, if the places in between make sense. So for example, if we were keeping track of how many rides we were riding and how much money we were spending, can you ride a ride in 2/3? No, you can't. Like, if you're on a haunted house and then like halfway through you're like, I don't do Frankenstein's, and you like get up and leave, you don't get like a discount because you only rode 2/3 of the ride. So you could use a dashed. But if like if we're talking about let's say like how many inches of rain it's raining, right? So would it make sense to have 1.5 inches of rain? Or how about 2.75 inches of rain? Sure. So all those places in between make sense. So you'd use a solid. So when you have a soft serve machine, is it going to be solid or dash? What do you think? Agreed. Okay. Let's see here, guys. Can I get you back up here in 5, 4, 3, 2, 1? Let's see here, guys. Henry, how did you fill in your table?
I did from 1 going up to 12.
So you went, I'll go 0, 1, 2, 3, 4, 6, 7, 8. I might stop at 10. And what did you fill in for your X's? Or your Y's, excuse me.
For 0, I put 0.
Mm-hmm.
For 1, I put 0.6.
Uh-huh.
Then 1.2,
Yep.
2.4, 3.6, 4.8. Then I did 6, just 6, I think.
6. That makes sense. Is it? Yeah. Is it? I don't know. I'm not sure. Hang on, because it's no 6 divided by 6 is 1, and 0.6 divided by 1 is 0.6. So that can't be right.
You skip 0.18 and point.
Aha! 1.8 and then 2.4 and then 3, 3.6, 4.2, 4.8, 5.4, and 6. That's what happened. You just missed those little ones. That's okay. That's okay. I love the way that you got this set up, though, Henry. How is that going to tell you how to write your equation? What's your equation?
I did y equals 6/10 x.
Awesome. 6/10 x, because 6/10 is the same thing as 0.6. We can actually reduce that, though. If you punch that in your calculator, 6/10, it'll reduce it to 3/5, and that's the way I want to see it. Another way you could do that is a lot of us did 6 divided by 10 and got 0.6. If you push this button right here, you see this little arrow key? It'll actually turn it into a fraction for you as well. So I would like to look at it as y equals 3/5 x. Beautiful. Now we're going to make our coordinate plane, guys, which again, I didn't tell you how big to make it. I told you to tell me. So let's see if I can get a little bit of help out there from drawing some empty seats. There we go. Rico, how far did you make your coordinate plane on the x-axis? I'm glad we're talking. How high up did your table go on your x-axis? 10, 20, 30, 40? So maybe we want to count by tens up to 50? So we can go, let's just go 10, 20, 30, 40, 50. And then I'll go halvesies 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I'm going to go the little spots in between too. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then how high did you get on your Y's, Rico? What was it? Oh, like how high did you get up on your y-axis? Like how far? Like if you went 0, 10, 20, 30, 40, 50, how high did your y's get? 30? Okay, so we can count by like maybe 5s up to 30. 5, 10, 15, 20, 25, 30. And you'll notice I'm not telling you what to count by. You guys tell me what to count by. You guys get to pick. 1, 2, 3, 4, 1, 2, 3, 4. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And the thing is, now we can graph this. Soft serve, gray, maybe for vanilla. So 0, 0 was one of our points. 1 and 0.6, kind of annoying to graph. I might skip over to 5, 3. 5, 1, 1, 2, 3. And then 10, 6. And then Rico, you counted by 10. So what was your 20? 20, what? 20, 12. How about 30? 18. So that's 20, 19, 18. Okay, how about 40? 24. Looks like that's around here. And how about 50? 30. Rico, should this be a solid line or a dashed line? Let's see. So when you're doing soft serve, here's how I'm thinking of this question. If you were like, I want a soft serve, and I was like, you got it, and I got this machine, and I was like, and you were like, keep going, and I was like, and you're like, keep going, and I'm like, and you're like, keep going. I'm like, this thing's gonna fall over. Like, let's say that I gave you a 20-ounce ice cream. At some point before I got there, was it a 10-ounce ice cream, Rico? Before that, was it a 5-ounce ice cream? Before that, was it a 2.5? Was it a 1.25? Was it ever like 4.8765 ounces? All those places in between make sense. And that's why we use the solid line instead of the dashed. That's why we use the solid line instead of the dashed. That's the difference. And I'll tell you right now, no one's going to test you on the solid line versus dashed line situation. And you'll notice my points aren't perfect because my coordinate plane's not perfect, but the idea is here, right? We have our points, we have our equation, we have a table. Yes, go ahead, Tice, and then we're going to come on over here. Tice.
What's our test on this?
It'll be, I haven't decided yet. Yes, go ahead. That's going to be a river. Oh, sure. Well, Rico did it. I just did this for Rico's table. If I was going to use, for example, you can put your pencils down. I'm not going to make you draw this twice. But if I was, for instance, going to use Henry's information, what I probably would do is just go like, because you get to pick, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then over here, maybe I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sure, why not? Sure, and you get to pick. Like, that's actually a huge thing that I believe in, is when I don't give you a coordinate plane, you get to pick whatever it is. I actually really like this one, and I want to show you why. 0, 0, and I don't want to do the decimal, so I'll do 5, 3. I'll do 10, 6. I'll do 15, 9. And if you're very observant, and I hope that you are, if you're very observant, you might notice that I could have put those points down without needing the table at all. I could have put those points down with this. Because this equation was trying to tell me to do that. But that's in the future. That's tomorrow. Today, guys, what I want to do is I want to give you a self-assessment. So if you guys will open up your planners to page Holy Bajoli. It has been a minute since we had to open our planners. What page could we be on? Page 60. Page 60. Page 60. So today's self-assessment is, are we on module 8 or 9? Now I don't remember. 8. 8.1, graphing proportional relationships. Graphing proportional relationships. Okay. And then, we'll talk about that next time because I'll put that on there. And by the way, guys, you might want to put down on here, on paper, this is actually a paper self-assessment because how do you graph on Canvas? So I'm going to hand that out to you guys, and we'll have at least 5 minutes to work on it, 10 if you want to, but you are winning the scoreboard game, so we'll see what happens. So go ahead, guys, hang on to your rulers. Don't put your stuff away yet because I do have your self-assessments. They're just not on Canvas. I'm coming around with those. Those of you